This video should be entirely review. If you feel fairly comfortable with simplifying radicals, what I would recommend is to go ahead and pause the video right now, attempt 2 or 3 of them, and then check your work and make sure you're on the right track, and then you can jump to the final video. All right, so for simplifying a cube root, what we need to do is find perfect cube factors, or 3 of the same factor. Since most of you may not have your perfect cubes or quartics or quintics memorized, what you may want to do is a factor tree. So 40, 4 times 10, 4 is 2 times 2, and 10 is 2 times 5. So we have 3 2's, or 2 cubed, as a factor of 40. So I'm going to pull a 2 out. My 5 that doesn't have anything tripled with it will stay under the radical. A squared is just a times a. There's not a group of 3 a's, so that will stay entirely under the radical. And b to the 8th we could rewrite as b cubed times b cubed times b squared. So the b squared will be left over, and we'll cube root those b cubes, those perfect cube factors. So pulling the 2 out with my negative, the a is staying under, and we have 2 perfect cubes of b. So I've got 2b's, or b squared, that I'm pulling out from the cube root. And left under the cube root, we have the 5 from 40, we have a squared and b squared. All right, example 2, now we are looking for perfect fifth factors, meaning groups of 5 numbers that are the same, or 5 variables. So for 96, we can start with 3 times 32. And if you have memorized that 32 is a perfect fifth, it's 2 to the 5th, that makes it a little bit faster. If not, continue with the factor tree. Since I know that 32 is 2 to the 5th power, I'm going to go ahead and pull a 2 out from under the radical. A squared, again, we don't have a group of 5, so that will be staying under. The shortcut for the powers is to take 7 from our b, divided by 5. We're going to pull 1b out, and there will be 2 left under the radical. And again, c cubed doesn't have any groups of 5, so that will be staying under our radical. So then we have the 5th root of 3 left over from our 3 times 32 to make 96. A squared, we couldn't pull anything out. We had 2 b's left over after we pulled out 5. And c cubed had no perfect fifth factors. All right, question 3. We're looking for fourths now. Well, 16 is 2 to the 4th power, so that whole expression will come out from under the radical. X to the 8th, if you take 8 divided by 4, you get 2, so we have x squared. And y to the 4th, 4 divided by 4 is 1. So we had a perfect fourth under our radical with nothing left over. Question 4, 64. Again, if you don't know the perfect powers, go ahead and make your factor tree. 64 is 8 times 8. And 8, if you remember, is 2 times 2 times 2. So we have a group of 6 2's. So we'll be pulling a 2 out from under the radical. X to the 6th, 6 divided by 6 is 1. And y to the 12th, 12th divided by 6 is 2. So again, we had a perfect factor under the radical, nothing left over. We'll do one more together, and actually this time I'm going to go ahead and do question 6, just to show you what happens if you do have a coefficient, and then you can try question 5. Looking for perfect cubes, 54 is 9 times 6. 9 is 3 times 3, and 6 is 3 times 2, so we have a group of 3 3's. We will pull the 3 out and multiply it by the 6. So 6 times 3 gives us 18. We have an x squared under the radical, that can't be factored out. Y under the radical, that can't be factored out. So we're going to pull out a couple of z's. 8 divided by 3 is 2, so we're going to be pulling out 2 z's in addition to the x y squared that was already outside the radical. And then under the cube root, we have left over a 2 from our 54, x squared y, from under the radical right here. And we had 2 z's left over after we divided by 6. So go ahead and try question 5.